Hello again. So we now know that we're going to be talking about the normal distribution. One of the first things that we're going to talk about is about a particular example that we're going to be coming to again and again, and that is the standard normal. Okay? The standard normal is the normal distribution with mean 0 and with standard deviation 1. Okay? And we will denote it by z. So z will be the normal random variable with mean 0 and standard deviation 1. Okay? Now, why do we care? Well, one of the reasons we care is that we have a table of areas for the standard normal. Okay? So, so in the past, you used to only have like access to tables, and you would have to do calculations by hand. And I have a table right here, for example. And what it allows you to do is it allows you to look at a normal, and it allows you to calculate the area underneath the curve to the left of a particular z value, which will allow us to calculate probabilities. Because as you remember from our first lecture, even though we haven't calculated any probabilities yet, we know that we're going to have to calculate the areas under the curve between certain boundaries if we're going to be able to calculate the probabilities of the normal random variables. And of course, since this is statistics, one of the things that is going to be of great importance to us is calculating probabilities. Therefore, the standard normal is important because we have a table of areas for the standard normal that we can use to calculate probabilities. Okay, number one. And basically, along the same lines, that table would be useless if it wasn't for this property. We can take any normal random variable and we can transform it to the standard normal using the z-score formula. We're going to talk about the z-score formula soon. We're going to see how to use it, and you're going to see what I mean by this statement in a more technical way, okay? So in other words, like I was saying, in the past, you only had access to the standard normal table. And so if you wanted to calculate some probability of interest related to a normal random variable that might occur in your work or in a problem that you're working on, what you would do is you would use the z-score formula. You would find the corresponding values on the standard normal, and then you would use that to get the probability for the problem of interest to you. Okay, and we're going to be doing that soon. Now, of course, let me be clear. As you might have ascertained from the way I'm saying that this was in the past, you might say, well, David, what would we do now? Or what's different about today? And of course, the difference with today is that you have hand calculators and spreadsheet programs and other software that can calculate the probabilities for any normal distribution. But I still want us to learn these things because they're helpful, because you might have to use a table, and let me see, and just because it's better that way, okay? No, and finally, we're going to talk about the standard normal because it'll give me a concrete example which will assist us in some of our discussions. For example, one of the discussions that I'm gonna one of the lectures I'm gonna prepare for you right now has to do with what I meant about the symmetry of the normal distribution. By using the standard normal, I'll be able to say things concretely in a way that will be clearer than if I was just speaking in generalities, and it'll allow me to say certain things that I might not be able to say as cleanly if it was not a standard normal. And in any case, these are the main facts you have to know about the standard normal. That it has a mean 0, it has standard deviation 1, and that it's important because because the values from any any normal random variable can be mapped onto the standard normal, and we can use that together with a table and a hand calculator to calculate the probabilities that we're going to want to calculate, okay? And with that, I look forward to seeing you again soon, and thank you so much.